What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're going to be talking about basically what I plan to do for the Ludum Dare 50 game competition this weekend. And we're also going to spend a little bit of time adding APIs to the Substratic Engine that we've been working on in the past couple weeks for accessing and handling user input events. And then we're going to try to wire it up to the game we've been working on called Crash the Stack. So in the way of updates, we have only a couple today because I've been having less time this week to actually spend on working on the projects off stream. But I did manage to finish the game loop implementation. So in the last stream, we were working on having a game loop that could deal with timing. So you basically have a frame time that you're keeping track of every frame so that you can do things like animations or game logic updates based on timing. So I did finish the implementation of that, and I abstracted it into the Substratic Engine, which I'll show you in a little bit. And it basically just gives you the ability to just give an updater function and a renderer function to the game engine loop function, and then it just takes care of everything, calculating all the deltas and everything. So that should make things a little bit easier getting started on another game this weekend, but we're going to use it today in the work we've been doing so far in Crash the Stack. I also fixed the frames per second counter that we started working on last week. I was doing a couple things wrong in the calculation, so I got that polished up, and we'll see it in action in the stream in a moment. Hello to Jackson. Thanks a lot for being here. All right, so Ludum Dare 50. So it starts this weekend. It starts around 4 a.m. in my time zone, which is Eastern European summertime since I'm in Greece. And I think in the United States, it starts Friday night, basically. Technically, it's Saturday morning for me. You can go to the ldjam.com website to see an actual countdown timer that tells you how long it is until the actual competition starts. So if you want to know when it starts in your time zone, definitely go take a look at that. I have a specific plan that I want to follow in dealing with the timing of everything. I'm going to start streaming somewhere around 7 a.m., somewhere between 7 a.m. to 8 a.m. my time. So I've got a link here where you can sort of check what time zone that is for you, but it will be different than our normal stream times, obviously. So for me, that's... Oh, wait, I put that, 7 a.m. Athens time is 4 a.m. Saturday UTC. It's midnight Eastern time, which is pretty late for some folks. And what is that? 10 p.m.? 10 p.m. I'm not good with 24-hour time. It's like 10 p.m. Pacific time. So a little bit late to get started. We're going to be rolling on this in the evening for any of you in the U.S., but anybody on my side of the world will be going through the day, basically streaming on and off, which is going to be great. Hi, Daigo. So take a look at that, and also I think you can add your own time zones if you want to check how yours is going to be in this setup. Then what we're going to do is, as soon as we start streaming, we're going to try to come up with a really simple game concept on stream, basically something that is finishable within 2 days. I'll talk a little bit more about how I'm going to approach that in a minute. We're going to design the concept, and then we're going to start, hacking away on the code. We're going to set up the project and the GitHub repository, and then we're going to start making commits. And I'm going to try to set it up so that hopefully you'll be able to try playing the game at some point throughout the first day. I'll get some basic things working, and then I'll try to get the publishing automation set up. Now, I won't go as far as to publish it to itch.io like I was planning before. What I'll do is just publish it to a GitHub release on that repository, and it will just have new releases every time there's been a commit to master. That should be good enough for people to get their hands on updated builds. If things go incredibly well and I make way too much progress, then I might get things set up so we can publish the itch at some point later, but I'm not going to hold my breath on that one. I think we'll be spending all of our time trying to get the game working. So I plan to stream most of my work on the game, but I might have to hack some off stream at times if the times for streaming isn't convenient. I'm living in my wife's parents' house. It's a very small place, and there's a lot of things going on right now. So we'll see how much I'm actually able to stream consistently. But I do want to stream a couple of hopefully 3 to 4 hour chunks on both Saturday and Sunday. So I'll start in the mornings and stream for 3 or 4 hours to get a lot of work done on the game, and then I'll go again in the afternoon. I'm not sure what time that would be, but I'll try to let you know by the end of the first stream, and maybe on Twitter or on the YouTube channel when to expect the next one to come. So make sure that you have your notifications turned on for the channel, either on Twitch or on YouTube to be notified as soon as we go live. And please come join if you are awake and available at the time, because it'd be fun to see, you know, what people think about what we're doing, trying to make this game live in 48 hours. I think it's going to be pretty challenging. So what kind of game are we're going to try to make? The type of game we make is ultimately going to depend on what the theme of the competition is, which is only going to be announced when the competition starts. So there's been voting going on for a while now on the ldjam.com website. Let's see if I can actually show you the current voting. Okay, so there's a set of possible topics that it's all been whittled down to. Delay the inevitable, fragile, make connections, mutation, teleportation, a single resource, folklore, shelter, infestation, road trip, tunnels, overgrown, out of order, spaces limited, combine, and garden. Now, all the people who are going to participate in this competition have been voting on which one ends up being the final theme. And there will only be one theme, and you can make whatever kind of game you want based on whatever the theme says. So if it's a game about mutation, then you have to have some kind of mechanic or storyline point or something that has to do with mutation. And, you know, it's up to you to decide what you want to do. So we're going to try to figure out something live as we are coming up with this stuff. But there's some constraints I'm going to try to follow when we come up with a concept for a game to work on. Hey, Luis and Robert, thanks for being here. First of all, no screen scrolling. Everything has to take place on one screen. And why is that? Well, because if you have screen scrolling, it requires either to have like some kind of tile map system or having, you know, pieces of images that could be scrolled around. And it just, you know, makes the game design a bit more complicated and also increases the complexity of the art resources that need to be created. So, you know, think like, you know, sort of like what we've been doing so far with Crash the Stack, where we have like a board where there's tiles on it and the screen doesn't really move. You just have everything about the game in front of you. So something like that. It won't be a board game necessarily. You know, think like even Pac-Man. Pac-Man, you have a game board that doesn't scroll, but everything that happens in the game happens inside the space of the screen. So it will be something to that effect. I don't know what type of game it will be yet. We'll decide whenever we start talking about the theme on Saturday morning, my time. And also no sounds or music unless I can quickly wire up something to play sounds or music. And I'm thinking that since this is something that I don't have the capability to do yet in the engine, it might be interesting to make this a part of the concept. So whatever the theme of the game is, somehow we'll have to work in the fact that there's no sound or music. So that might give us an extra factor to make the game a little bit more interesting or make the concept more interesting. So it might be cool. We could use it to our advantage. No sprite animations, but I might animate the motion of certain game elements. Sprite animations require, you know, a lot of drawing, and since I'm a programmer and not an artist, I would rather avoid having sprite animations for right now. But we might, you know, make things rotate a little bit or bounce up and down, or who knows, like, or even just animate the motion of things moving on the screen. So we'll try to do some things like that, but definitely no sprite animations this time. And also stick with a simple retro pixel art style because, like I said, I'm not an artist. So we're going to do some really janky programmer art. But that's okay because the point of this thing is to try to make a game in 48 hours. And I'm not trying to make the most beautiful game in the world. I'm just trying to make something that actually works. So you may be thinking, well, why so many constraints? Well, it's because the language and the game engine we've been working on are still extremely new. And there's a lot of functionality they don't have yet. So I'm going to keep things simple for myself. So that I can actually have a chance at writing a complete game in 48 hours with everything that I've implemented so far. Now, we'll probably add more functionality to the engine, to the language, etc. as we go, because there's obviously going to be things we'll need. But we've got a pretty good foundation so far based on everything we've done up until now. So I think that it won't be a huge amount of things that we'll be adding, but there's probably will be some things that we'll need to add. And if we do future game jam events, which I would like to do at some point, my ambitions will scale to whatever we've built in the engine and in the language by that point. So for now, we're going to do something really simple, but later we may do something a little bit more ambitious depending on what functionality we have at the time. So we'll keep working on this kind of stuff over time. I think after we finish sort of the game jam this time, we might switch back to some of the other aspects of what I wanted to build on this channel, and then sort of, you know, interleave the game development with other stuff. But we're building all this code into the same set of projects so that they can be used among each other. So I think that anything we build for other creative aspects would still apply to games. So hopefully over time we'll have more functionality that would be useful in future game jams. All right, so for today, we're going to try to finish up our preparation for the competition this weekend by working on user input, because so far we haven't really implemented anything that allows you to press buttons or mouse clicks or anything in the game to interact with what might be a game. So we need to actually make this work. We have to wire up some kind of APIs for user input. And luckily, the core library we're using, GLFW, actually does provide APIs for handling input events. So we're just going to create our own APIs in the Substratic library to wrap that, and then put together something that is a little bit more straightforward for our mesh code to use in the game engine. So for now, the goal is just to take the user input events like keyboard, key press, or mouse click, mouse move, etc., and create an event data structure that we can pack that information into, and then create a stream of events out of it that can be handled by the game. And then we probably also will need to have an API for accessing the state of the individual keys. But for now, I'm going to try to avoid that because, excuse me, because I would rather have an event stream approach compared to a key state approach. But we may need it later. We'll see whether that happens or not. All right, so the tasks for today. Write some C APIs that wrap GLFW's keyboard and mouse input APIs, which probably shouldn't be too hard. Also create event data structures for keyboard and mouse events, which I've got some ideas on that. We'll figure out how we'll do it. Then provide an API for accessing the input event queue. So we're going to need to treat this like a queue, say, ask for what the next event is, and then handle it, and then keep basically iterating over the next event until there's no more events left in a particular frame of the game. Then we can try to wire up basic mouse and keyboard events in the Crash Stat game that we've been working on so far. Obviously, we'll need mouse clicks at the very least, because if you're going to match tiles in a Mahjong game, you either need to be able to click on the tiles to be matched or use your keyboard to select them. For that game, I actually do want to have both of those things as an option for input, but the keyboard option will require a little bit more design thinking, so we'll have to do that on another stream. All right, so that's it for now. We'll come back to this task list as we make a little bit more progress. And I apologize if I have to keep clearing my throat during the course of this stream. I picked up a cold over the last week, and it's been like the worst that it has been the last couple of days. So yeah, we'll see how it goes. All right. I think I've already cloned down all the stuff that we need. So let me go ahead and just try to run the game and see what happens. Okay, so we have our FPS counter here that you can see in the upper right-hand corner. Looks like the FPS is doing pretty good, which is great. On my other machine, it was capping to around 60 FPS, which, is probably what I really want. But, the fact that this is moving faster than that is also fine. So it's nice to be able to have that readout as we work on things and get a sense for how fast the language is working. So far, it looks good to me, though. Let's actually check the CPU usage and see where we stand on that. About 8.5% CPU usage. So yeah, not bad. All right, so from this point, let's go ahead and look into what the APIs are for GLFW's input handling. Then we can start wrapping that stuff. So documentation, HTML documentation, input guide. Okay, so I haven't looked at this at all, so we're going to learn it together right now. GLFW provides many kinds of input, while some can only be polled, like time. Time, huh? Interesting. I didn't know they had a function for that. Or only received via callbacks, like scrolling. Many provide both callbacks and polling. Callbacks are more work to use than polling, but it's less CPU intensive and guarantees that you do not miss state changes. Okay. So it sounds like there's a couple different ways we have to handle input, but that's okay. We'll add whatever we need, and then later we can add other things. All input callbacks receive a window handle. By using the window user pointer, you can access non-global structures or objects from your callbacks. And to get a better feel for how the various event callbacks behave, run the events test program, whatever. GLFW needs to pull the window system for events. Event processing normally done each frame after buffer swapping. Okay. Even when you have no windows, event polling needs to be done. I mean, we've done some of this already, I think. Hey, Mr. Bill. Let's see. In Substratic Engine source. renderer. We had an input function at some point, but maybe I got rid of that. So let's actually create an input.c file here, and then an input.h file perhaps. And let's go to renderer.h. We're going to steal a couple things from here, actually. We'll steal the inclusion guards, and we'll also steal the module init function signature, because we need that eventually. End if. Subst input module init. These are going to be both subst input h. Input. Okay. We also need to include that just keeps happening. Mesh.h. All right, so now we're going to go into our input.c file. We're going to include, thank you, input.h. And then we can expand this function out. And then we can start by trying to add some of the things that we're going to need. First of all, we're probably going to need to pull in GLFW's header here. So if I go into renderer.c, I think I have this that I need. So I'll pull in this GLFW 3.h header. Let's see, GLFW poll events. There are 3 functions for immediate processing pending events. GLFW poll events processes only those events that have been received and then returns immediately. This is the best choice for rendering continuously, like most games do. So that's probably what we want. If you only need to update the contents of the window when you receive new input, GLFW wait events is a better choice. Well, that's not us, because we want to have a live game engine. It puts a thread to sleep. Definitely don't want that. Let's see. Post empty event. If the main thread is sleeping, hey Fade, you can wake it from another thread. Okay, fine. So I think we are calling this somewhere, if I'm not mistaken. I think GLFW poll events. Let's just check our code base for that. GLFW poll. Yeah, so in this window needs close P, I'm calling poll events because I need to check to see if any window system events, like, you know, whenever you're raising a window and you try to close it, the window manager, the windowing system tries to tell the window, hey, close. So GLFW poll events here make sure that we can pick up that event. So we're already calling it here. It might be better to call it somewhere else, but we're not going to deal with that right now. We're just going to try to write some functions that can deal with the input. Also, I think that what we need to do here is set up this set key callback for keyboard input. So it receives the keyboard key, platform-specific scan code, key action, and modifier bits. So we can set our own callback function up, which we probably need to do. Excuse me. So here's what I think the design is going to end up being. Each frame call an input update function like subst. Well, let's see. Input update. Something to that nature. Input update, yeah. And then input update will manage a queue of events. That can be accessed with the functions input event peak and let's see, input event it's either like take or DQ, but maybe take is better. It's a more straightforward function name. So these two functions, you would be able to call input update first and then call the peak function. And then if take or peak returns nil, that means there's no more events left to deal with. So we're just going to have some internal state that we're going to manage for this. So let's see. We don't want to have a bunch of global state hanging around. So we might need to have an object we pass into these functions that is sort of like the input state object. And that could be sort of an opaque object that the internal C functions can manage. So we might think about that also. Like, let's say type def struct subst input state. And then there could be something here, like let's say a value array. What was it called? Mesh value array. Let's see. Value array. Did I have anything else using that? No. It's going to be in the mesh code base. Let's take a look here. Excuse me. Okay, so object, I think, no, it's in value.h. Here we go. Value array. Array. Value array. Okay, so value array is a type. So if we have a value array, then we can use that as a queue effectively. Input events. And that's not a pointer. It's actually a an inline struct. So let's see. We could pass it around as an object. So then if we were to do that, let's go ahead and start writing the shape of some of these internal functions. So value, excuse me, subst input update MSC. Is that right? No, capital V. Let's go steal the signature from one of these other functions because I can never remember. Okay. So here I'm going to paste in this and then delete the extra parentheses. Excuse me. Okay. We can do the same thing for the input event peak and input event take. I'm wondering if we should change the naming a little bit, but I'll deal with that in a moment. I think it's probably not the right time to start messing with that. Okay, so we also need to register these functions. So I need to copy this thing here. Also need to fix how I'm registering these things because there is a better way to do it. If I were to look at string.c, yeah, so I think I just need to take that ampersand off. Yeah, that's it. Okay. So here I'll change this code to have input update. Input update. Then we'll paste two more. One for event peak. Louis says, David, I think we caught the same thing. I'm always also coughing around. Yeah, it's, I don't know. I think this is like the last cold of the season before everything goes away. And it's kind of nasty. Excuse me. This is going to be challenging. I may have to talk less at some point. All right. That sets up the wiring for these functions. And we will try to write some of the necessary behavior for this. So maybe we will also need object pointer. Let's see. Create input event create pointer. I don't know. Well, we may need a function for this. So because we need to have a, what was it? Type def struct subst input event. We're just going to try to sketch this out. I don't really know how it should look yet, but we're going to find out soon. Now, if we're going to hand this off to mesh, we're going to need to have a way to understand what the values are for this thing. So the reason why I say that is because we're going to need something like a, let's call it a type def enum subst input event kind input key up. So we're going to basically start input none, key up, key down, mouse left up. Mouse left down. I don't know, I'm just sort of, making this up right now. Mouse right up and down. And that would give us the information about which, I don't know what CCLS is thinking, about which type of event we're dealing with. So we could have here subst input event kind. And then we may need other information like what keyboard key was pressed, etc. First of all, let's take a look at the APIs we're going to have access to here. So we have key. There's key constants for what keys there are. Okay, good. Action, GLFW press. What other actions are there? Press, repeat, release. Okay, so they've sort of made that orthogonal to, key or mouse button was pressed or released. Interesting. So how about, we'll think about whether we want to replicate that in a second. For now, we'll just try to move forward a little bit. So we got a little bit of the information we need here. Let's just, leave it at that for now. This is going to be a subst input event. This is going to return a mesh object make pointer. And interesting. Question is, does it need to be heap allocated? No. This is the first time that I've had a value structure that doesn't need to be heap allocated. It can just be copied around. Where I would want to pass that along to mesh. Everything else has been heap allocated pointers to a specific type. So, I don't know why that just happened. So I either have to heap allocate this input event, or I have to have another way to pass something that's not heap allocated along, just as a value. But yeah, I mean, it could be done. Well, no, it needs to be pointers because otherwise we'd have to have the actual size of everything. So that makes sense. We'll just do it this way. So we will say subst input event pointer. Well, that's not actually perfectly correct, but whatever. Equals malloc size of subst input event subst. I don't like that whole subst prefix anyway. Okay, I forgot a semicolon. Okay, so now I've allocated that. I need to do like a mem copy. And I don't remember the signature for that at the moment. Include, I believe, a standard lib, right? So mem copy. Whoops. Let's find out where mem copy is. I'll put this right here for now so we don't get screwed up. Then, let's see. I think it's the target and the source, and then the count, I believe. Yeah, target, source, count. Target is event pointer. Source is event. Count is 1. Now that we have that, we can use, we need to have this VM, okay. VM, and then the pointer itself, event pointer, and then whether it is managed or not, and that is true in this case, we want it to be freed by the engine. So that should be enough. I got a lot of errors here, but I think it's just subst input event kind. No. I think it's just the language server not knowing what's going on. I've had a lot of problems with eglot and CCLS lately. Okay, so that takes care of that. And that would allow me to, in this function, start pushing things onto that value list. So first of all, we need to grab. Let's go back to render.c. Let's steal a little bit of the code that we have here. Like right here. So object pointer, and then we want the subst input state. Subst input state. Okay, that should give us the input state that we already have. We'll have to make that a heap allocated object as well. We also need some kind of input init probably, so we're gonna have to put a function in for that. So input init. And it'll probably need some parameters at some point for dealing with, what type of inputs we want to support, but we're not going to deal with that at the moment. So we'll have an init function. We also need to do a similar thing like with this, subst input state equals malloc size of subst input state. And then we also need to input it with respect to a specific window. So we're going to have to pull the window parameter too, I think. So if we do this, then subst window. I really need to have some macros to make this stuff easier. As I always say, include window.h. And then so input init, we get the pointer as the window. We create the input state. We need to do a mesh value array init on the input state. What is it called? Oh, gave me something here. Input events, okay. So if I use the reference of that, I should be able to pull it. Okay. So that will set up the input state object we're allocating. And then here we're just going to return a pointer to that to mesh. Input state is the pointer we want to return. All right, that should be good enough to initialize input. Excuse me. So now we've got an initialized input state object. We've initialized the event array inside of it. Now we should be able to pull it out of the argument here. Oh, we also need to do an object val on this. I missed that. Object val. And for this one, probably also needs to be a value. So object val. Because we're going to just pass this directly into a call to push it onto the value list. Interestingly, I don't have a real queue data structure at the moment. So when we're taking things off the front of the array, we need a way to put them back there. So it's almost like we need to have a circular array. I'm not going to deal with that right now. We'll deal with it another time whenever we have to. I mean, we could basically say there are only up to some certain number of events allowed. And if you haven't been actually taking the inputs for those, then we just start dropping them. I suppose it's possible that we could do that if we wanted to, just as a way to make it simpler. But having an actual queue data structure might be better. I mean, having a queue wouldn't be too hard, because we already have... Yeah, actually, we have a const data structure, so maybe we don't need. Okay. Well, all right. We'll deal with optimizations later. For now, let's just get it working. All right. So input init works, or it should work. Update. We're gonna need to. Let's see. What would we return from input update? I mean, let's just return t, because right now I can't think of any other value that is going to be helpful here. But we do need to do some checking here. So, oh, input update. This actually doesn't even make sense. Because by this point, okay, maybe it does make sense. So what we'll do, okay, if we don't actually call that GLFW poll events function, then having an input update function doesn't really make a whole lot of sense. What we do need, though, is to set up that callback they were talking about in the documentation. So here is where we need to set up input callbacks. And we have the window handle. And if we look at window.h, we can see that it gives us the GLFW window inside there. So okay, GLFW key set key callback. I also need to check window.c. What was it called? User, come on. User pointer. The renderer is what gets put there. And the renderer, does the renderer have a pointer to the window? Yes, okay. So we do have the ability to get back to it, what we need. Cool. All right, so here's what we'll do. In input.c, we will say GLFW window equals window. Oh, we don't really even have a variable for that. GLFW was a set key callback. Window GLFW window, and then the input callback, and we'll define that function now. So void, whoops, yeah, whatever. Void input callback, GLFW window, and int key. Well, let's just do this. Let's just copy the text. There's no point in messing around. This will only be for keyboard input. Okay, so now we have this input callback function. Probably we're going to need to hold on to... this is a little bit interesting. So the callback only has access to the window. The window can give me access to the user pointer. And the user pointer in this case is going to be a renderer object. So that means that the renderer needs to know about the input state object. Gives us a little bit of a circular, circular reference, I think. So if we go to renderer, well, no, that's fine because it's not a header reference, I think. Going to be in renderer.c. So in renderer.c, we're going to look at input. Well, no, that's wrong. All right, let's take a look at this. I think it's going to be problematic. We'll see if it's a problem. Subst input state. The renderer should not have the input state. I mean, it just seems kind of ridiculous to have that. The window should have it, but then okay. That's fine. All right, let's go to window.h. The window will have it because it unfortunately has to have it. So we'll have include input.h. I think this is going to work because input.h does not include window in its own header. It only includes it inside of its implementation file. So this should be safe. I hope so. Input state. Excuse me. All right, so now we have the input state in subst window, and we'll just leave it that way. The renderer doesn't need to know about it, but window is sort of like the interface between the engine and the operating system. So for now, we can just sort of leave it there. And now that we have that, there's two things we need to do. First of all, we need to say window input state equals input state. And then in this function, we can pull out that user pointer. So GLFW, let's just do this really quickly. There was another function, user pointer. Right there. Okay, so we're going to do this. Oh boy. Okay, I think it's fine to pull in renderer. Sucks, but don't have a choice really because that's the way that that's set up. I mean, maybe there's like an engine state struct that we're going to need at a higher level. That could be something we look into. Okay, so subst renderer equals. Does it just automatically cast that? That doesn't make a whole lot of sense. Subst renderer star. Okay. And then we're going to use that GLFW. What was it? Set key callback to get the renderer window. No. That's wrong. We got that already. Yeah, so we just need the access to the input state. So this will give us access to the subst input state via renderer window input state. Okay, so that sucks a little bit, but it's fine. We'll deal with it for now. To do don't have subst renderer be the top level engine state type. All right, so now we have input state, and that means that for any key input we see, we can create an event for it. So what we would do with that is mesh value array push, I think is what I called it. Let me double check that. So value.h, no, write is what we called it. So value array write. And then we need to give it a mesh memory. I know we haven't actually. Oh, whoa. We don't have access to that, do we? Does anybody have access to the VM? Oh boy. Interesting. So at this point, we haven't really wired the mesh VM through into the engine. But we kind of need it at this point, unfortunately. So window may be the place for that right now, because window is a first place that we actually have contact with mesh and the engine right here. So the first thing we do is create a window, and that implicitly knows what the VM for mesh is because we're calling a mesh native function. So maybe the window needs to have a pointer to the mesh VM, which, you know, makes me feel a little bit more nervous too, because we're throwing yet another thing that doesn't really belong inside of the window state object. But like I said, we're going to deal with it for now. All right, so VM we'll have there, and then inside of window.c, when we create the window create the window here, we're going to say window VM equals VM. Nope, we're going to cast that. So VM star mem. I mean, technically speaking, we could not call it VM and just call it mesh memory. Maybe that's the better way to do it. A little bit more obvious. How about this? It makes me feel less disgusting. Mesh memory. And that needs to be a pointer. Cool. Now, we've assigned that. That's all good to go. And then we need to go back to input.c, and then we have we still need the window. Renderer window mesh mem. Okay, so that's solved now. And the other thing we need for this function is the value array itself, and then the value to be pushed. So this is going to be the input state, input events, but we need the reference to that because this is not a pointer by default. And then also we need to have the input value that we're going to create. So input event create pointer, input event, and now we're going to create that input event based on what came here. So subst input event, and then we can try to create that instance directly. Dot kind equals, now action, may need to do a little bit of if statement on that, but what we can really say is if, I'll do a ternary operator here. If action equals GLFW press, then this needs to be the input key down, or was it? Otherwise, input key up, okay? That's kind of horrifying, but whatever. That works for now. That creates the input event. We also need the key as well. And that's going to be the scan code. It's going to be an integer key code. Int key mods. Or maybe let's just say modifiers. Oh, goodness. Always nice to get scared by the notification sounds. Cool. Oh, thanks, RumbleTumJum, for following on Twitch, I think. Okay, so now we've got the input event set up. Everything should be ready to go. So now we can start trying to see if this is going to crash horribly. Maybe we want to add some print statements in here just to see what's happening. So before we do any of this stuff, let's just print some things out. So printf key callback. Yeah, we'll just get the values of these. Key, scan code, action. And that's fine for now. We also need to go into the project.msc file for this and add that input.c file to the list of input files. So let's go right here and say input.c. Let's just try to build it and see what happens. I'm sure we get some kind of problem here. Okay, this did not work for sure. Let's see. Unknown type name subst input state window.h. I think that's because I need to move this to the header. Both of these things to the header. Oh no, just the input state right there. We're gonna take that, we're gonna put that into input.h right here. Okay, let's try that now. Input.o, no such file or directory, so something else is going wrong. Incompatible pointer type in renderer.c. Let's go fix that little thing right now because that's always a little bit of an annoyance. Then input.c GLFW window undeclared. So input, it's line 43, GLFW window, window. Okay, so that needs to just be plain old window. Now we're running again. Still no such file or directory, so something else happened. Line 50, incompatible argument type, argument 1 of input event create pointer. And what is that? All right, so we're gonna change this now to a mesh memory. And On this mesh object make pointer, we're going to pass a mem here. I think that actually needs to be a VM, but we'll see in a second whether that's right or not. Input event create pointer, create pointer. I need to pass one other thing here, which is going to be that mesh mem. Where was that? Ah, right here. We'll just copy that in. Okay. Now build it again. Something else failed. Let's go back. VM undeclared line 58. Okay. Array init. That takes... Oh, interesting. Okay, doesn't even take a VM. Not what I expected. Too many arguments to function. Array init. Okay. Anything else? 82. Input update. We'll just take that one out for now. I think that should be everything. Nope, something else. Input.c line 34. Incompatible pointer type. This needs to be a VM, I believe. So VM star. I need to get these things fixed up. VM undeclared line 64. This is mem, right? Yeah, mem. Mesh object make pointer, VM star, because I know that those takes star or VM pointers. All right, this time it seems to have compiled. Good. So now that we have that compiled, we could actually go into, let's fix this too. This is wrong. Substratic input. So that's what this module is going to be called in mesh. So we're going to go to main.msc. We're going to pull in substratic input here. We'll just clone this line, go change this to input. And then we could try to define input is input init window. So we're going to initialize the input state. Yeah, let's try that. All right, so undefined variable input init. Let's see why that's not happening. Input dash init. This is exported. Substratic input. Let's see. What else did I do wrong here? Substratic input. Oh, I didn't actually add this to the lib file. So lib.c. We'll go here and add in input module init with the VM. And that should add that so that it shows up to mesh. All right, so that did work. Now we have the input system initialized. Let's see. So now, excuse me. In main.msc, we should be able to start, well, actually, in theory, if I start pressing keys, it should show them. So let's run it again, see what happens. F, no. Oh, I probably need to set my input state in EXWM. That's fun. Okay, so that didn't really help. No input events yet. Let's make sure, whoa, something really wild happened there. Oh, no new line. That's fun. Because the input wasn't being flushed because I didn't write a new line at the end. So those keys did actually show up, after all. Let's try this one more time. All right. Cool. Yeah, so we're getting up and down events now for whatever, code. Oh, what was that? Ah, the super key. It even picks that up. Cool. All right, so we're getting input events. That's awesome. And then, in theory, those should be getting written to that input event list. So now we could try to implement the behavior for peek and take and see how that goes. So take is probably going to be more interesting at first. But what we do need now, because we've written this in a way that requires a little bit of state management, if we're going to continue using this value array and not a linked list, Then we need a cursor to the first value in the array, because if you start taking values out, then we can't be looking at the very first item of the array anymore. I mean, it'd be nice if I could shift the items, but at the same time, I don't want to do that. Excuse me. Because, well, I mean, it's not the worst thing in the world. I could add a function to value array to allow you to shift the memory, because we can just use the, what was it called? Mem move function to just shift those values over. So maybe like if you take 5 items out of the array, then it will shift the memory over so that we don't have to keep like pushing the array bigger and bigger and bigger over time. The alternative is to use a list like consts. But if I do that, then I have to keep track of the head of the const list and also the last event, so it's easy to add new entries. And that requires more heap allocations, which I don't like, unless I keep an object pool of consts, which is also a possibility. Just trying to think this through. Yeah, I mean, we're already dumping key events. So dumping a const every time we pull something out is not the worst thing in the world. So long as the garbage collector doesn't get hit too often, which I don't think it will for now, but later maybe, who knows. So the question is, do we go for shifting the array? I guess the question is, how many key events do we think are actually going to get put into the array? Okay, so per frame, how many keys can a person press? And if you think that the user, so that the game loop is going to drain the event queue every frame, which it should, then, I mean, you're not going to have any more than, what, like maybe 10 keys plus a mouse key at the same time? I mean, I don't even know if it's even possible to have that many keys pressed at the same time. Well, I mean, guys, in sequence per frame. Maybe it's not a big deal. Maybe I'm overthinking it a little bit. So yeah, we're back down to the idea of still using the array or not. Let me see what it would take to add a function for this. So for every 5 events we take, it would shift it over. I don't know, it just seems more complicated to have to do that. Maybe I should go with a const approach. And if I go with a const approach, then what does that mean? That means that in my input state, in, what is it? Input.h, instead of a value array, it's going to be object cons, first event, object cons last event, and then we would just, keep eating the car of the cons list until there was nothing left. Okay, so let's take a look at what that looks like in implementation. The place where that happens is right around here. So maybe let's call this input key callback, because now I think we have to have mouse callback functions also. So let's do this. And I'm thinking about this because we're going to need to push new events. So what I do there, void input event push. Mesh memory. Oh, let's just do this. Just copy it straight up. Oh, come on. All right, so event push. So we need some of this stuff here. So we're gonna copy that information into a heap allocated structure. But we're not gonna return the object val. We are instead going to set it into an object const. So object const new head equals mesh object make cons, and that is a VM star mem, and then the car is going to be the this thing here, this whole object value. I think that's enough, right? Right there. Okay, and then the cooter is going to be the existing head. So that's going to be, where is the input state? Subst input state. Input state. All right. Whoops. Let's do that. Okay, now input state. And that will be the first event. All right. So we allocate the new head. Huh. Okay. Now this is complicated because the cons. Ooh. Tricky. Since the cons is not going to be directly accessible by any other existing GC root, I need a way to capture the cons. Okay. Maybe. You know what? I think we need to do this differently. We're not going to use a cons for this. What we're going to do is make the input event itself a linked list. What they call this, an intrusive list, intrusive linked list. Yeah, intrusive linked lists. I think this is a good idea for this specific use case. So what that means is that each input event will have a pointer to the next input event. And that way we can do the memory management a little bit more cleanly. So what we'll have here is a subst input event next event. And then whenever we create one of these, we need to initialize that to null, input.c. Subst input event. Oh, come on. Subst input event. Just trying to find the place where I'm initializing this. Right there. Okay, so here also we want dot next event equals null. Will you clean that up for me? Thank you. All right, so there we go. Should I just go ahead and allocate one of these? I guess what I'm doing is fine. So then the function I'm writing here is input event push. Let's call that input event push. We're going to pass in the memory. Nah, we're not going to do that now because we don't need to. We're just... Yeah. Okay. We don't need this for now. We're going to use this somewhere else. We're going to use this actually right here. In both of these places, actually. So we'll leave that for later. For now, create pointer. I don't know that we need it. Yeah. So input event push And we can change this function to not take a mem. We just need the input state and the event itself. Cool. This is starting to look better. All right, so input event is event pointer. We're mallocing it and we're copying it. And what we need to do is in the input state, we're going to say the event pointer next event equals input state first event. And then the first event is now going to be assigned to event pointer. And then we're done. So we're just, adding things. That's not right, is it? Damn. That's not right. That's making a stack. So we still do need to have a pointer to the last event. And we need to move this now, which is fine. I'm going to move this stuff into the header. Now we actually need to have access to the input event. So here, subst input event, first event, subst input event, last event. Okay. Fine. Now, we'll change the ordering of the stuff to where input state last event. How about this? We do this first. Input state last event equals null. Input state first event equals event pointer. Input state last event equals event pointer. Because if you have no last event, that means you have no first event either. And then if you have only one event, then both the first and the last are going to be that same event. So then that sets up the first one. Otherwise, if there is a last event, we're going to go do this. Input state. Come on, I keep missing the underscores. Input state last event equals event pointer. Last event next event equals event pointer, and then we're going to do that thing that I did before. Here we go. Last event next event is event pointer, and then last event. Yeah, that's right. Okay, so we're updating the whatever the current last event is to say that its next event is this event pointer, and then we're also saying the current last event is now this event pointer because we need that to be the one that gets added to the next time an event gets pushed. Push the event into the linked list. All right. So this can go away now. I think that function's done. So now event take. Let's think about that one. Take the first event, remove it from the linked list. So what we're going to do is say subst input event equals. Now, if there isn't an event, if it's null, we'll deal with that in a second. First, we need to grab. Let's do this. I don't know if I have one of these already. All right, subst input state. All right, so now we have the input state. We're not going to use that. We're going to just, oh, hold on. Input event equals input state first event. If input event is not equal to null, else return nil val. Okay. So if it's empty, just return nil. All right, so input event, then what we'll do is say that input state first event equals input event next event. If input state first event equals null, then we also set input state last event equals null. Make sure to clear out the last event if we have no more events. Okay. Let's do that. And then we need to return an object pointer. So we're going to do this number here. Return object val. Event pointer is going to be the input event. And we're going to delete this part of the code. Okay. And to duplicate this for the peak function, which I don't really know if we need yet, but I'm adding it just because it makes sense to sort of have it. Input event is first event. If input event is not null, then just return that event. We're not going to modify the input list at all. And then otherwise return nil if the input event is null. Let's make sure that we're initializing those things correctly. So no longer do we do the input array init. We do input state first event equals null, then last event equals null. Okay. I think that's good. So what we can try now is, well, first of all, let's just compile the code and see if it works. Well, that part is working, but do we have any errors in the code? Unknown type name subst input event input.h20. 20. Say what? To be self-referential, I need to have a struct here, I think. And this is no longer needed. Excuse me. Oh, and I got a typo in input.c at line 21. Is that right? Yes, subst input state. Okay. Building again. I saw another error. Too few arguments to event push. Oh, right. Okay. And that's going to be input state and input event. We're just going to delete that code. Now we're good. And now if I start pressing things, nothing crashes, which is a good sign. And then now let's go into main. We have a nice little spammer here from Twitch. The game update function. So here's the thing I said earlier that I was going to show you and I just haven't gotten around to yet. Two things. One is that I've got this concept of making an FPS counter. And the design for that is kind of cool because it uses closures. So if I go to modules, Substratic Engine, scheme mode, make FPS counter. So basically what it does is, well, why did I have a new line there? It creates a local context for the FPS and last time variables, and then it returns a lambda that wraps that as a closure, and then it can basically just be a function that you call to update the FPS, and it will just do all the calculations itself. So then whenever in main.msc I call the current FPS function, it just returns whatever the current frames per second is, or nil if it can't actually calculate it yet. So then you can just render it directly. So kind of nice. I'm happy with how fast the code is running currently. Kind of promising, I think, for being able to use this for actual game development. The other thing to show is the new run engine loop function, which basically just asks for a renderer, an update func, and a render func, which we've defined those two here, game renderer, game updater, which updater doesn't really do much right now. But it will in a second when I start looking at key events. So yeah, it just calls those functions every frame. And internally, what it does is does all the calculations for time step, and also make sure that we are we're calling the update function in a way that catches up to what the frame rate should be. So kind of nice. I was following a particular article. What's it called? Fix your... What was it? Not fix your posture. Fix your time step. So this seems to be a commonly referenced article on time steps, and kudos to my friend Alex That's Amore for pointing it to me. But this article is basically what I used to implement this strategy for the time step. Anyway, back to what we were doing. So now what I need to do is try to use my functions for taking those input events just so I can write them out. And for now, I'm returning them. Actually, there's one thing I need to check. Let me go back into input.c. So when I return these instances for the take one, I definitely want it to manage those pointers. Because when I take it off the list, now this code has no access to that allocated memory anymore, and somebody needs to free it. So mesh is going to be the one that frees it. But on this one here, on the peak, we don't want it to be managed by mesh because we're not actually releasing ownership of that object yet. So we're going to say false here so that it doesn't actually try to collect this object whenever it goes out of scope. It will delete the pointer wrapper, but it won't delete the underlying object. Fade says, I must have missed a session on the subject because I don't know, but is mesh garbage collected? Yeah, it's definitely garbage collected. It's a very simple mark and sweep garbage collector. That's what the book that I read had as an implementation. Later, I'll probably do something like a generational GC, or if I implement continuations, I might use like the Cheney on the MTA garbage collector scheme as well. But that's later. Okay, so what we want to do in addition to fixing that GC thing we just did is we need to have functions that let you extract information about the key event or the whatever type of input event it is. And this is kind of interesting because we have to generate some objects, I think. And the reason why I say that is that let's actually write the code that we would use for checking key states. So let next event, and this is going to be a recursive loop, basically. In fact, we can take this out now if we're going to have this let here. So let next event is event or input event is input event take, and then input state is what I called it. Yeah, input state. Okay. So this will give us the input event. Now, if input event, if it's not nil, we'll do something with it. Otherwise, we just won't loop again. So now we'll say next event is input event take input state. Okay, so this is a loop that will give us input events. So here, display got an input event. We don't know what it is yet. We just know that it's an event, but we can display the event object itself, display input event, and then display new line, since I don't have formatting yet. All right, that should be enough to dump the event list on every frame. So let's see if that works, or if it crashes horribly. Okay, crashes horribly. Exiting game loop. Oh, okay, interesting. It's because I didn't return a non-nil value. That's a kind of a nasty way to do this loop. Ooh, how am I gonna do that? Oh. If not, window needs close. Okay, so for the else case, I'm gonna return T. Make sure we don't exit the game loop. All right, let's do this. Okay, so, what was that? Got an input event, and then it died. Read memory access, printing the object. It didn't like that. dereference of a high value address. Okay, so did I do something wrong with how I return the object? Let's go back to this. Oh. I need to check this first. If input event is not null, okay, that should be doing the right thing. Printf, no more events. And then here we'll say returning an event. Just to see what's going on. Fade says that'd be super interesting. I guess you're referring to doing the continuations, etc., or the different garbage collection schemes. No more events, blah, 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 blah. And then eventually it crashes. Okay, so let's not write this because I think that's self-explanatory. All right, so we got an event. Returning an event. Mesh object make pointer mem input event. This is a pointer. That all looks good. First event equals next event. Yeah. Okay, so that should be fine. So if I go into main, I just don't display the input event, is it okay? Seems a little bit ridiculous. Yeah, okay, it still crashes. Okay, there's a static trace that's useful. Line number 87. What? Okay, so if input event is not null. Huh, okay, hold on a second. When I'm pushing this event, I copy the event information into the event pointer. Then input state, last event, blah, 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 event pointer, everything's there, everything's good. In theory, that next event should still be null because we copied the information over. So back in 87, is it that input state? No, input state's not bad because we wouldn't have gotten to this point if input state wasn't a valid object. So we're setting first event equal to input. Oh, wait, what? So input event also is not null at this point. Printf took event. I'm just going to write out whatever is part of that just to see if we got any garbage in there. I'm kind of curious to see if it's garbage. Input event arrow. No IntelliSense. Fantastic. And I call that, let's say, key code. Did I actually put that in? Probably not. Okay, let's do that. Again, I gotta go back to input.h. Next event. Key code equals key. Key modifiers equals mods, I think it was called. Okay. All right, that gives us that information. And then if I go here, I can say key code. Now see if it actually writes that out to check if it's not garbage. Okay. So now if I go back. Okay, so it is garbage. Something is wrong here. First event. So up until now, everything has been fine because the first event has been null because we set it up that way. So that means that the next event, no. For some reason, the event itself is bogus. Let's look at our push function. Event push. first event. So last event is null. All right, here we go. Printf adding first event. And let's also say what that is because I'm curious. Event key code. How about that? All right, that's good. All right, adding first event, key code was 70. That looks right. And then input state, first event, event pointer, input state, last event, event pointer, and everything should be copacetic at this point. But let's double check that though, because maybe this is a problem. How about that? Let's take a look at event pointer. All right, so F. Okay, garbage. Why did mem copy not work? All right, so mem copy. Something I'm doing here is wrong. This must be the problem. Oh, the values of num bytes. So it needs to be the actual size of the object. Whatever, size of subst input event. This probably will fix the problem then. F, all right, cool. F. So, yeah, looks like that did work. All right, that's working. Cool. Let's get rid of some printfs now because we do know this works. That one, let's just leave it for the moment. This one we can get rid of. This one we can get rid of. Okay. So now the last thing we really need is to be able to tell what the key is and what kind it is. And this is the point where we have a little bit of a problem because we need to send a value into mesh that can be read to tell what it is. In fact, let's excuse me. I'm having problems controlling my tongue. Let's see what input event says here. What was that? Dereference of a high value address. That's really weird that it chokes out on this. Because it should print it. Oh, interesting. Okay, so mesh object print object.c 464. Type name. Oh. No, pointer type is not there. I did not initialize it right. Bug. Okay, so make pointer. I forgot to do this. Pointer type equals null. So I added a new thing where you can create a pointer type that has a little bit more information attached to it, like a custom free function, etc. And apparently I forgot in the old code path to to clean that up. And still it's not working for some reason. What? 464? Come on now. Consistency. So 464 is not null. Do I have to be that explicit? I didn't think I did. God. What is happening? Am I in the right file? No. Okay, this is the wrong part of the code. Let me check here. I'll just copy this file over. Get rid of this. Okay, so this is from a different folder. This is the risks of working in multiple projects like this. All right, so crash, deps, mesh link, compiler, source, object.c. Paste, delete. We should be good. Yes. All right. Cool. All right, so now we can see we have a pointer object being printed out, blah, 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 whatever. Excellent. I should probably check that in. So object, make sure to initialize pointer type to null when not provided. Whatever. All right, push that, good. So now, now we can actually read the input event. And like I was saying before, to check it, if, let's say, input event key code, that part's relatively simple because we can just say, well, either we need constants somehow that map to those numbers, or we need to be able to pass in a key, actual string and say, this is the key I'm looking for, and then convert that into a code to check. Which is possible, I think. C switch string value. Yeah. I don't think it's possible to do that. An if else ladder. Yeah, whatever. Yeah, if you have a hash function. I mean, I do have a hash function. I could use that. Let me copy this, since I mentioned it. I'm going to copy it to the notes. Actually, I want that, probably. I need that page. Okay. So, back to what I was thinking. To actually check the key, let's see, input event key code. Input event. We need to check it and see if it's equal to something. So it would be nice to compare it to an integer or a number. So if I were to say like equal the key code to some constant that has a number in it. I mean, I suppose I could just have all the constants defined in mesh. Input key code F. I'm not crazy about it, but I've never actually set up a constant in mesh that gets used somewhere. So let's just try this really quick. User pressed F. All right, we'll get rid of these two lines. And then we'll do the next event thing. I also don't have any kind of case statement in the language yet, which is going to be really interesting when we start getting into nested key checks. But I might end up going with some other structure to make this work. We'll see how that goes. All right, so input key code F. I can actually go into deps, Substratic Engine, modules, Substratic input.msc, define module Substratic input. So I can do the sort of mesh side of the module definition and define input key code F, excuse me, as whatever the value it should be, and then export it. So let's see, key E, key F is 70, right? So we'll just say 70 here. We have this whole list of values that they have defined for the keys. So let's just start with that, and then we can go and add the rest in later. I might go do that on my own time, so we don't have to sit there and watch me, copy and paste constants. Or like even like a WSAD maybe would be more interesting. So how about D? Where's D? D is 68. Because WSAD is pretty, likely to be used in a video game. So we'll go alphabetically. A, D, S, and W. And then for A, it's 65. D is 68. S is 83. And W is 87. Okay. Now let's go back here. We'll check it for W in this case. Input key code W. Next event. Yeah, that's good. All right, so now I should just be able to run this, I think. Okay, so, uh-oh, what did I do wrong? Oh, undefined variable input event key code. Okay. So if I go to input.c, I need to add another function for this, key code. Okay. So then I can just copy one of these. Let's copy this one. And then subst input event. Okay. Now let's just extract the key code value. So let's return number val input event key code. Should be good enough here. Okay, so now if I press F, does nothing. If I press W, it says user press W. Okay. Also, I want to check to see if it was an up or a down press. I need a function for that. Input event key down question mark. Key down. Okay. So then I'll have another function for this. Key down. And then we're going to return a bool value for this. Key, so this is going to be kind equals, was it input event key down, I believe. So let's see. I'll go back to input.h. Input key down. Okay, so maybe I should make this have event on everything just to be more clear. I know it's more verbose, but it's fine too, I think. Okay. Now, if I have this, then I should be able to go to main.msc and say and input event key down input event, and then also have the equal be checked. Uh-oh. There was a key up somewhere there, I think I saw. Input C key up. All right, so this needs to have event here also. There we go. Okay. Now I'll press W, and we only get that event once. I'm trying to watch the FPS to see if it dips anytime I press a button. Doesn't really seem to be doing it. Okay, good. All right, I mean, that seems to be working okay for now. It's not the cleanest implementation in the world, but it does work for now. So we can check if there's more key that's down. And then see if it's down. Maybe if I say key up. I mean, if I were to say key state or key action, maybe. then I would have to return a symbol. And I don't really want to do that yet. So having a predicate function makes a little bit more sense. So we could make a few of these repeat. Not perfect, but, you know, it works. All right, so it was key up. And then we want key repeat. Do I have that in my list of... Yeah, I need that here too. Yeah, that was what I needed to do. Yeah, I'm gonna need that. I mean... That does tell me I need to do something about configuring key repeat. But what about... Sometimes these, cache key event state does not poll the system for the current physical state of the key. Whenever you poll state, you risk missing the state change you're looking for. If a pressed key is released again before you poll its state. Okay, so they say key callback is the ideal version of this, so if you see key down, you can assume that it's not going to be released until you get the key up event. Okay, that's fine. So let's just leave repeat out for now. I'm not going to bother with that because that's only really useful if you are doing like keyboard input where the user is typing into your app. Then you need to have like letter repeat. Like you hold the J key and you want to repeat J a million times. Let's also fix this. This needs to be key up. Okay, in the remaining 15 minutes we have, let's try to quickly add mouse events as well. And see how that goes. All right. So now if I go to look at the input.h, I have another shocking event sound. Excuse me. Welcome to iRogue32. Thanks for following. So I need to have a way to check the mouse details. So mouse input, cursor position, set cursor position callback. I don't care so much about the position. I only care more about the clicking and where the position is at the click event. When the cursor is disabled, raw mouse motion can be enabled. Cursor objects, I don't care about that. What about clicking? Mouse button input. Mouse button callback. And button action mods. Okay. So it seems I'll need both. So I'll have to have a cursor position callback. Whoops, I didn't want to do that. I want to copy this. All right, so now we'll go back into, what was it, init in input.c. Come on now. Right here. Okay, so I'll paste this in here. Cursor position callback, window, GLFW window. GLFW window. Then we need an input cursor position callback. We can copy this really quickly. Cursor position callback. And it seems to be the only way we're going to get access to the mouse position, which is fine, I suppose. So that's double pause X and double pause Y. Double pause Y. Okay. So I might need to start breaking up these events a little bit into substructs, but I'm not going to worry about that just yet. Or maybe I will. So subst input event. Then we could do something like a type def struct subst input key event, which would have a subst input event inside of it. Then we could do that. Then we could also do a input mouse position event. Double pos X, double pos Y. And then a mouse button event. And this would have int, what would it be? There's something for mouse buttons. Action GLFW press. And modifiers. What would that even be? It kind of tells you what it is. So I don't know if we even need anything special for that, because the kind will tell you if it's that kind or not. So maybe I'll just take this out for now. So we'll have two specialized event types, which also means that we need to change some of the internal implementation details for this. This now needs to be an input key event, right? I think I messed this up a little bit. Oops. Then this also needs to go down. All right. So that should be happier now, I think. And then this may need to get... ooh. Yeah. That complicates this a little bit. So if I were to convert this into a key event and then pass it into input event push, the new copy that I make, yeah, I think I need to just make the object. Okay, so let's just stop messing around here. We're not going to do any more copies. We're just going to create the actual event with the right size. Not going to do that. Then we'll just say event pointer. We'll just do the mundane setting of things directly, kind equals, and then just do all this crap. That's fine though. I mean, this is just going to be easier all up. And also event pointer, key code equals key, event pointer, key modifiers equals mods, and then this right here can be deleted. And then this event push can now actually take the event pointer directly. Event pointer. We'll just call it input event still. Input event. Then, let's see. Event pointer, input event. Yes, 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 yes. Okay. And now in this one, I don't have to do any more copies. I can say this is now an event pointer. Or even an input event. How about that? Input event. Then I'll do the same thing here. Rename those three. All right. So that pushes the event on the stack, or on the queue. And then that is fine. Now I also need to have a similar implementation inside of the cursor position callback. So let's go ahead and paste that in. Mouse position event, and we're just going to call this mouse event. All right, input event, whatever. Just make it easier to deal with. Mouse position event. Kind is now going to be mouse move. Hey, Peter. Yeah, a lot of new things happening. All right, so input.h, we need to have a mouse move. So this is going to be mouse move event. Go back to input.c, and this is going to be straight up input event mouse move. And maybe this should even be mouse move event and not mouse position event. So it's giving me the actual position, not the delta, right? Because I don't really need the delta. Mouse position event. Can I do this? It's gonna, whoop, that's not what I meant to do. Whatever, fine. Input mouse position event goes to subst input mouse move event. Got those two. Let's go to input.h. I'll rename those also. All right, okay. Got that. Input mouse move event. Was that other one an input key event? Cool, great. All right, so now we have the kind set. We also need to set the pos x equals pos x. And pos y equals pos y. Okay. That should do the trick. Now, set another one for mouse move. Oops. And then we also need for mouse X and mouse Y. We can move those right up here with the rest of the non-predicates. Or maybe not. Let's keep everything together. We'll do this. We'll just reorder it a little bit. Mouse events. Keyboard events. Okay. And we'll do this as well. And we can say mouse move on that one. That will tell us if it's a mouse move event. And then similarly, we're going to grab the numeric values of position X, position Y. So mouse X is going to be a number val. Input event. Oh, okay. We need to be casting some things here also. So we're making some assumptions about what type of event it is. To do check event kind. So if I'm going to assume this is a mouse move. Excuse me. Event. And then when I have that, I can just return the pos X. And then I can do the same thing for pos Y. Okay. And one thing I'll probably want to do at some point is turn on or off the event handling for mouse movements, because that's going to be kind of intensive on CPU, I would think, if you just get the mouse movements all the time. Might be better to pull for the mouse position rather than doing the events. But for some kinds of apps, events probably is better. All right, let's see what happens then. Maybe I should write something out in the cursor position callback. Okay, so printf mouse move x y. This is going to be a floating point number. Okay, and then we're going to put in pos x, pos y. Now we'll see if we get any readout from that. Okay, not happening yet, interestingly. But I do register it. Pretty sure. Set cursor pos callback. Cursor position callback. Okay. Let me just double check that it didn't get written out after the fact. No? Okay. Oh, wait. Hold on. Got some errors here. That's why. Okay, subs input key event has no member name kind. Oh, right. That's right. 40 input event dot kind. I think that's what I need to do here. Yep. What else have I got as errors? 58 event dot kind. Yep, because I'm using the substruct. I need to set it through that. And 117. Same thing here. I need to actually update this to be key event. This is going to be fun. Key event. All right, so I'm going to do some pace around on these because they are needed. Key up. And then that's good. I think I need to do this also, the event.kind here. So I'm going to copy this around on that. So is that enough for the key events? Let's check it out. Okay, it's not doing anything yet. Let me double check. Okay, 117. Oh, no, that's my mistake. I shouldn't have done that. Key code's fine, but event.kind does need to be checked that way. Also for this kind, I also need to use event. Okay, let's see what happens. Uh-oh. So it compiled that time, and now mouse move is giving me trouble. So mouse move. Input state. We allocate the mouse move event correctly. We set the details of the event. Input mouse move event. Input mouse move event. I should have allocated it the right size. Printf before push. Let's just see if it's the push that's the problem or anything else. Interesting. Before push. Okay, so is it the push that's the problem? Could be. Who knows? After push. Okay, so it's not inside the position callback. I guess I should be reading this, huh? 105 GG. Last event equals null. Input state. That should all be right. All right, I won't spend too much more time on this because we're already over time. Let's see. So it does tell me the mouse move, which does make sense. But when we call input take, it's line 103, first event, next event. Did I not initialize that correctly? Maybe I didn't. So let's double check what I'm doing. Input, yeah. Here we go. Event, next event equals null. Am I doing that in the other one? No, not even doing that here. Okay, so that's a really risky thing. Once again, crash. Maybe, oh, here we go. Input event, next event. Oh, great. 44, yeah, this needs to be event dot. Okay, right here. We'll just put that there. And then also for the mouse event that we're initializing, we're gonna do the same thing, delete that. Boom. Now we're getting our mouse events. We're also getting our key events. All right, so let me delete the mouse move here. And we're also going to go into main.msc, and then we can check if input event mouse move, input event, display, mouse moved. And I can also put the X and Y positions in, I think. String, append. This is going to be nice and fun. Number to string. Input event mouse X, input state. And then we'll put a Y. And I'll copy this, move it down. Hey, Gavin. It's going pretty good here, making some progress. And then a new line. So let's compile it, see if it works, and then we'll be done. Oh, something not happy. Mouse X, line 136, 136. Input event, pos X. 136. Yeah, it's accessing the event. If it's a mouse move, and it tries to display the information about it. Mouse X, input state. No, wrong. Input event. Really need some type checking in here. All right, boom. Mouse moved. That's actually coming from mesh code. So all that writing out is it's event handling from mesh. Let's just double check that, make sure that it's for real. Boom. See, now you get all that nice little output written out saying that there is a mouse move, which is pretty obnoxious if you ask me, but it does validate that the mouse events are working. So I'm not going to add mouse click stuff right now because it's pretty easy to add that. It's just a matter of wiring it up. I think that it's good enough to see that keyboard events and mouse events are working and we can read them in mesh. So that should be enough for whatever we need to do for a game for Ludum Dare this weekend. I'll probably polish it up a little bit more tomorrow and check some more changes in so that it will be ready to go. And yeah, I think that's going to be it for today. So definitely keep an eye out for the streams this weekend. If you missed the beginning of this stream, just check the show notes. The link is in the description below. It sort of gives my plan for what I'm going to do for streaming this weekend. But I'm going to start bright and early on Saturday morning, streaming my development for the game for Ludum Dare 50. So if you're around, if it works for your time zone, definitely check it out and follow what I'm doing, because I'm going to try to see what I can do in 48 hours. I'm going to have to be very practical and pragmatic to get anything going. But, you know, that's what we do every stream here, so it's really no different. So anyway, thanks a lot, everybody, for being here today. Really appreciate it. And until next time, keep it creative. We'll see you.